I've been excited for this one all week. To tell you the truth, I was just telling Dee that we jumped on here, and before the actual recording happened, I was talking to my wife, and I was like, wow, I get to interview the Godfather of MLOps himself today. This is like the biggest. Let me just put this into a little bit of perspective. Before most of us that are on this call even realized that we wanted to be doing things around machine learning or MLOps, Dee had already written the biggest papers in the space. So that tells you a little bit about who we have on today. Dee Sculley, thank you for joining us. I really appreciate you taking the time, especially because you don't do this much. And so that just makes it 10 times more an honor for us to have the pleasure of interviewing you.
Well, that's very kind and a little bit embarrassing, but I'm really happy for the conversation.
Well, I think we can start it off with one thing that is top of mind for me, and that is you've written these papers which are very instrumental in the MLOps world. And for those who don't know the papers that I'm talking about, and you probably have, even if you don't know the name Dee Sculley, you've read his papers, because these are the papers that everyone gets told to go read when you start learning about MLOps. One of them is the high interest technical debt of machine learning. And then you have the other one, which is the ML test score. And both of these have aged really nicely, being that it's already 2021. You wrote them in 2015 and 2017, and they're still the top papers that you need to go out and read. So my question to start out with is, what's changed since you wrote those papers?
Yeah. So first of all, thanks for the kind words. If the papers are still relevant, that's really nice to hear. Or maybe that's good news. Maybe it's bad news. I'm not sure. So yeah, I mean, obviously the world has changed a lot in the last 4, 5, 6 years in terms of machine learning, the importance of machine learning across the world, the number of people who are doing machine learning, the number of folks who are working on MLOps and ML infrastructure and things like that. Like it's night and day, in terms of the broader world compared to what we saw then. I think some of the things that are different, number one, there is an MLOps community. That's really good. In many ways, the papers that we put out, at that time were sort of codifying as best we could the experiences that we'd had, working, as teams and groups within Google for many years about, sort of what we were finding were, the issues with machine learning systems that didn't appear in traditional publications. And it was a little bit hard to get those noticed and attended to. And really in the last, several years, whether it's because of these papers or because, folks have hit those problems themselves and are solving them in good ways, I think that there's much, much more awareness now that these are fundamental issues that, having, system level reliability is different than having model accuracy. That model accuracy is important and good, but that model accuracy by itself does not guarantee system level reliability. And so looking at the unique role that machine learning based systems have within larger production pipelines, that's something that really is now, I think, it doesn't require me to go around saying it a whole lot anymore. Like folks know, they're working on it. There are lots of folks who are now much more expert than I am, and it's really neat to see.
One question on that. You mentioned that now it seems like that's more obvious, but I actually feel that people still need to hear these old best practices, things that maybe we've been repeating over and over. Why do you think that, I guess recently that's become more obvious? Is it in light of more tools or more communities growing around these sorts of problems? Or is it just the research as well that has changed and shifted the direction of things?
I think first and foremost, there's just more people doing it. And so, when you have the lived experience every day, it becomes more a part of the conversation, whether it's folks in industry or wherever else. The fact that there are jobs titled MLOps, like this is different than it was 5-6 years ago. The fact that there are podcasts about MLOps, like that's different than it was several years ago. So these are obviously important issues. They're obviously not something where you're going to, have the opsifier that will, be the one little thing that you add to a system and solve everything, right? These are deep, complex issues that in many ways, you're never going to flat out solve. You're really going to manage in different ways, and so that requires, judgment. It requires, making important trade-offs, and so you need a community around that.
One question I have is, as Demetrius said at the top, these papers are still classic. I was just reading the high interest credit card paper this morning as a refresher, and it felt like you were talking to my team for some of the issues that we still need to kind of think through in terms of specifically. I think in that paper or the test score paper you mentioned, tight integration between engineers and researchers on a team level is really useful. I guess my kind of question to you, Demetrius kind of asked us what's changed. Do you feel that machine learning systems are more easily capable of being system level or reliable at a system level now than before? Or are we still, from your perspective, still grappling with some of the same sort of educational challenges that people need to understand in how they design these systems? Or are the tools advanced, you feel, I guess?
Absolutely, the tools are advanced. Back in the day,
Oh, wow.
Every pipeline was a one-off adventure. And some pipelines were really well engineered, or had been around for, some number of years, but there wasn't the level of general infrastructure that was looking to offer these sort of, large scale integrated solutions that are maybe, turnkey is probably too strong a word in my opinion, but there are, many different platforms that are attempting this right now, and with, I think, reasonable success in a lot of cases. The idea that you could say go to the cloud and have a production pipeline up and running that at least has reasonable ways of addressing many of the issues in the tech debt paper or on the test scores, I think a great advance for sure.
So I'm gonna throw David under the bus right now because, and I'll preface this with, David is a huge fan of the ML test score, and I know he's like an advocate at his company for using it. But there have been some people that said they don't quite agree with it, and David can give more color around it. But I'm wondering if you feel like what you were writing was for the general public, or was it your experience and you just wanted to make sure that others knew that this is a thing? And David, maybe you can jump in and tell us where people were giving you some slack on what the test score was. And I think it was around automating stuff, right?
Yeah. And it was well received, by the way, just to preface that too. But yeah, there was definitely some, not concerns, but some caution because, we work in a drug discovery space, so it's a little bit high stakes. And when you're in that situation, automating everything isn't always the best. Sometimes it can actually be problematic. And so for when I was, what I did was I decided to do a research project on one particular model, which I looked at as like a mini system. And I went through the criteria and evaluated it, used it to come up with some actionable recommendations. And a lot of them were focused towards, let's say, people that were in a production system where maybe they needed updates in real time. Maybe they needed to have automated triggers or events that trigger a retraining job. So they were looking for, an environment that is as automated as possible. And I think that's actually a good thing, right? Because it reduces error. In some cases, it can actually catch, again, when there's manual intervention, sometimes things get messy. But in a very, high stakes domain, sometimes you need those manual interventions to actually curate the results. Does this make sense from a scientific point of view? And in those situations, they found it a little bit like more, it's like overhead to try to implement some of these things. And I think I've heard that elsewhere, like trying to automate things and make everything continuously integrated and continuously deployed can actually add more overhead to your system and make things a little bit trickier. So you may not need all that, but that was just to answer, what Demetrius was talking about, that it was just a little bit of pushback on, over automating things and trying to make everything just like this, fully automated system.
Yeah, I think that that's all, really totally reasonable, right? I mean, if you're in a drug discovery domain, or something like that, it is unreasonable to have a model that's just going to go off and discover drugs without human intervention, right? Like that's not how the world works.
Exactly.
And what's useful in that situation is that you'll have, in the end, the downstream validation is going to be looking at one particular drug, and it's going to go through, all kinds of validation, whether it's the FDA or whatever else, that's going to show whether that specific output, one prediction essentially is good or not, right? The test score was really written for situations where you don't care about one prediction, you care about millions or billions of predictions per day. And in that case, you're probably not going to go full FDA on each one of those individual predictions.
I think that makes a lot of sense. And that was one thing I actually really like, though, that we got from that is we realized we needed to improve our coverage over basic things like the data transformations, what do we have a schema on the inputs that go into our model? And that seems kind of obvious, but when we went through that, I realized we're actually missing a lot of these things and we could do better. And that's what I really loved about it, is it actually, by evaluating it, I was actually able to see areas of improvement and come up with some action items of what I can actually do to pay that debt down and improve the system, to make it more robust. Which what I think the goal of it is, right, to measure the production readiness of a system. But I do agree, it makes, if you have like a system that has like millions of outputs and then there's all these things going on, it's so much more important to do things in an automated fashion, right? Because manually keeping track of all those things, it just will get super messy.
Yeah, and that's great to hear that, like just using the checklist, like in the end, it's not so much about, if you don't score 17 out of 20 or whatever it is, then the ML police are going to come and take you somewhere. It's really about the process of asking the questions, making sure that each of the important questions that you're asking yourself, that you have a good answer to. And the good answer might be, oh, we need to fix something. Or the good answer might be, actually, we've done a great job here. Or the good answer might be, we thought about this carefully and it's not needed here. All very reasonable. But I think it's important to ask each of those questions.
And I'm wondering, since we are talking about the ML test score a little bit, now, is there anything that you would add on to it that you feel like, okay, we've seen parts significantly evolve in the ecosystem. What else is needed, or do you feel like it's still good?
Let's see. So I don't think there's anything that I would take away from the tests. But the world has certainly evolved. There's some interesting pieces there. One is, if I remember right, and I could be wrong, but I believe this is true, that the ML test score paper was one of the first papers that made a key point of looking for inclusion, what we might think of as fairness issues or bias issues, and that models should be explicitly tested for things of that sort. And that was, like 2 paragraphs in an 8-page paper. I think that it's fair to say there's an awful lot more that you could say about that now, and many people have, and there are much better, sources for that kind of work than this paper. But certainly expanding on issues of bias and representation, especially for models that interact with data that deal with users or humans or people, is super, super important. Let's see, other stuff. If I remember right, and like, you'll forgive me, but like I had to go back and remember what was in these papers myself there. So if I remember right, we talked about stratified testing in that paper, where or sliced analysis, where it's really useful to make sure that you're not just looking at one aggregate, say, accuracy metric or goodness metric, 98%, oh good. but breaking that down into subcategories of the data. And what those subcategories are is going to depend problem to problem. Maybe it's looking at performance per country, or background color, or whatever it might be. I still believe that that's a really important thing. It can help you identify areas where maybe your model isn't going to be performing as well. But we've also found that there are other forms of domain shift that are useful to think about. And so what I mean by domain shift is, what happens when the data that your model is deployed on, out in the world is different in some way than the model that was trained on. This is the sort of gotcha scenario that machine learning papers tend to sort of look past with a little, let's assume that they're all IID. And, as we all know in practice, this is the sort of problem that happens every single day in every single model we've ever heard of. So putting together useful tests for these domain shift problems, I think, is really, really important. And so two additional kinds of tests that I can think of. One is, explicitly looking at shifted data, where you're finding some source of data that is a little bit different than the data that it was trained on. Okay, data was trained on a stream from North America. All right, let's try it on data from South America. Or images came all from iPhones. Okay, let's make sure that we test it on Androids. Or in these images, all of the key, objects of interest are nicely centered. What happens if they're slightly rotated? Whatever it might be. Again, problem to problem specific. But assessing data on that, assessing models on that shifted data, I think gives a much better sense of robustness that's super important for deployed models. The second form of shift is what we have called contrastive, or what might better be thought of as like counterfactual testing. So this is done by manipulating little bits of individual examples and seeing how performance changes. Yeah. So this is done a lot in the ML fairness literature. So things like, what happens if you have a sentence where the doctor did his thing and switch it to her thing? So it's a small counterfactual intervention with the words in that example. Hopefully the model doesn't go crazy. And if it does, it'd be really good to know. And you've seen similar things with, there's some neat papers where, folks will do like Photoshop copy and paste of images onto different backgrounds or things like that. So anything that we can do to intervene on our data to create specific counterfactual examples, these allow then sort of like a nice example by example way of analyzing where the edge cases for our models might be. Let's see, other stuff I would add. And I guess, David's going to tell me that the more stuff I add, the more stuff he's going to get flack for. So sorry about that. I think one last thing, maybe two last things. So I think that it's often the case that we don't push our models to the limits of their capabilities when we're verifying them, and finding, like, what are the edge cases? What are the real boundaries? If a model gives good performance when predicting on an image that's 32 by 32, in terms of resolution, what happens if the resolution gets halved? What happens if it gets cut to a quarter? What happens if it's just 1 pixel? For an audio model, what happens, as we degrade the sound more and more, or lower the volume, or whatever it might be? Really understanding what are the boundaries of our models, and where are the performance limits. I guess the other major category to think about is something that's happened between 2015 or as we call it now, the dark ages, and now is there's a lot more deployment platforms than there were then. And this is true, whether you're training in the cloud and deploying on mobile devices, or whether, like things are getting shipped off to little stuff in the web, or whether, you're training on CPUs and serving on fancy special hardware, whatever it might be. And each of those paths is a unique path that needs to be tested. And so, as we get more and more options there, there comes a combinatorial explosion that really does need full integration testing.
I think oh, sorry, Vishnu, go ahead. You go first.
Yeah, that piece of being across platforms, across deployment platforms, there's machine learning in the browser is something that appears to be something that's popular now. On device, that's certainly a use case that I actually work on in the cloud. One question I kind of have jumping off that point in particular is, as an engineering lead that's very familiar with building machine learning systems for reliability, how do you try and triage the technical debt that could occur from all these sort of like cross-platform interactions? What advice would you give to other people that might be in your shoes thinking about that kind of cross-platform work?
Yeah, let's see. So there's a wonderful phrase. I didn't come up with this phrase, but it's Google internal around when should you test, and the phrase was something like test until fear turns to boredom. And
that's a good one.
In general, we probably need to be testing more than we'd like to. In terms of triage, like, yes, absolutely start with the the quote unquote most important ones. But I think one thing that the last several years has shown is that reliability is really, really important. There are no small mistakes. And if there are errors, they're going to get spotted and they're going to get publicized, and they're going to impact users' lives. So I think that the bar is really, really high, and that it's worth spending the effort to ensure really strong reliability.
I think that makes a ton of sense. I think the key in doing any of this triage or thinking about reliability is understanding the risks of what it is you're trying to do. And I think early on your papers about the test score and the high interest credit card were really about pointing out, okay, these are the risks when you try to put machine learning into production in a way that doesn't pay attention to all the details. And I think you're right in particular that there's a risk now that your model's failures are publicly spotlighted a lot more, or that they have more impact on a larger scale because more people are interacting with machine learning systems. David, what do you think?
Yeah, I read your most recent paper on underspecification, and I see that it's like you extended some concepts in the ML test score, and I just wanted to talk about the stress test a little bit more, which I thought was really cool because the first time I think I saw something along those lines was there was this paper on NLP, and they were showing like counterfactuals and like the impact that could have on a model, and I thought that was really good because I haven't seen many tests that go that deep into what's actually going on or what the model is learning or what the outputs of the model are. How did you go about, coming up with stress tests? Because I find that can be a bit difficult. Like, all right, like you said, if I need to consider all these risks, there can be so many, especially when your model's deployed out in production, right? There's so many. I mean, is even the risk of people messing with your model, right? Getting it to like learn something that it shouldn't learn. So there's like all these issues. Like, how do you build that into your stress test without, coming up with every combination that's possible?
Yeah. Let's see. So that paper, the underspecification paper, I think it had 39 authors, something like that. It was a lot of authors. There was some meme that got put out like 7,000 authors. I don't know. But one of the reasons why there were so many authors on that paper is because the approach that we took in that paper was to ask domain experts. We looked at whatever it was, 6 or 7 different domain areas to sort of see if we saw the same phenomenon occurring in each of those domain areas. But in each one, we needed the domain experts to guide us in terms of like what are the most salient stress tests. What are the sort of what you might think of as the sort of causal structures that you'd want to see preserved. So I don't think that we have a full answer. Ask a domain expert is really, I think it's true, but it's a little bit flip. I would like there to be a more automated system. Sorry, Zoom keeps closing my screen. Okay, I'd like there to be a more automated system for coming up with stress tests. I believe that this is going to look like a useful way to encode expert knowledge about domain areas. And there are probably some, some people probably have really good ideas about, the right way to take like a knowledge graph or something like that and turn that into stress tests. I haven't done that yet, but I think that that's probably the right direction to be pushing. But yeah, like in the end, each of these issues is a problem-specific issue, and so like it's difficult to sort of sit back and say always test for this kind of counterfactual or that kind of counterfactual. But I do think you should at least always ask the question of like, what are the right counterfactuals to be thinking about?
Yeah, I was just going to say, even if there is always some element of domain expertise that's required to really evaluate this, there's still some general things that apply. Like I was reading this book on resilience engineering or chaos engineering. I've seen some, and I think they're really cool because the idea of how do I bring robustness or how do I make my system robust is something that's not just specific to software. Like a lot of systems are trying to build in robustness. And I think in machine learning, it's not, it's like we're also trying to figure out how do we do that. I still think it's a very hard problem. Even when I was trying to write tests for like a model, I was just like, man, what do I do? Like, it's like I always default to the basics of like data types or the range of values, something that's not really, evaluating it as it should be, and that's where I find there's not much help I've seen like online when I try to find like, how do I really make this model robust? It's something that I'm learning right now. And it sounds like there is definitely some room for improvement in that area.
Yeah, I mean, in the end, the reason why it's a hard problem isn't because, people aren't really smart. People are really smart. But the issue is that, we use machine learning to solve problems that we don't know how to solve with traditional code. That's why we have them. It's because we don't know how to specify the behavior in advance. And because we don't know how to specify the behavior in advance, testing that we have the behavior that we wanted to, have is a fundamentally hard problem. It's not just one where people haven't thought about it enough.
For our listeners, I think a lot of people have had the chance to read the credit card debt and read the test score papers. Underspecification paper, we read it and it was great. I would love to know in your words, maybe how you would, what the lesson you took away from the experience of writing that paper is, and what
the underspecification paper.
Yeah, the underspecification papers. Like, how has it impacted your thinking about engineering ML systems now?
Yeah, so for folks who haven't read that paper, for me the key takeaway was, let's see. So for a long time, people have worried about especially back in the dark ages when we went from sort of models that were trained with convex loss functions to all bets are off, deep learning, non-convex, blah blah blah. There was a lot of worry about like, well, wait a minute, are the results going to be reproducible? Things like that. And empirically, what's happened is that folks have found, by and large, the results on IID test train splits for deep learning models tend to be really pretty repeatable. I mean, not exactly, not byte for byte, not to 6 decimal places for each prediction, but really pretty repeatable. And what this paper looked at was what happens when you do an evaluation of repeatability in training deep networks, and you look not at an IID test train split, but you look at one of these stress tests that's explicitly from a slightly different distribution. And there what we found was that actually a lot of that repeatability went away when we look at out of distribution performance. And so this was just with like the minimal possible changes that you could have from model training to model training. It was just varying the random seed that was used to start the models. Everything else remained constant. And we saw pretty large variation amongst different versions of a model where each version was trained with a different random seed on things like perturbed versions of ImageNet or interesting genomics use cases or stuff like that. And the range of that variation was often larger than the range of variation between, say, a good model and a not so good model in like some ML competition on that task. So qualitatively quite large. For me, this is A, really interesting, and B, a little bit worrying, because if a given random seed changes your performance on out of distribution data, and we believe that out of distribution data is something that we encounter every single day in the real world.
That's exactly what we encounter, right? Like it's so messy.
Yeah, then we maybe do have some issues on repeatability there. So I think that there are some reasonable solutions. You know, like in one of our other recent papers, you know, we found that model ensembles, you know, like just taking n copies of the same model, but maybe with different random seeds and ensembling them together, gives a lot of robustness in these domain shift settings. Like obviously there's a some additional cost to be paid in terms of both inference time and in terms of system complexity, but there does seem to be some really nice robustness benefits that are consistent across domains and across application areas. So that's one takeaway, but my main takeaway from this is just that, you know, while it really is important to be evaluating models on these out-of-domain stress tests and to make sure that we understand the implications of what we're thinking about when we're in deployment land.
I was just going to say, yeah, that's definitely the case, right? That real life data is a lot messier than what we train on. But one thing I just wanted to ask a little bit deeper. You mentioned, if I recall correctly in the paper, that you're not just referring to like overfitting, right? Like you're getting data that's like your model is not, it can't generalize to. This is something a little bit different, right? You're referring to, if I just change like the random seed, like change it from 1, 2, 3 to 1, 2, 4, my results vary so much when that really shouldn't make much of a difference, right? Like the random seed should be something that, I don't know, maybe it's like a parameter you tune, but often that's not something I would like tune in a hyperparameter tuning suite, right? Like
I would hope not.
Yeah, like, that's that. But you know, but I guess the paper shows that had an impact, and like you said, that's worrying because the real life scenario is your data is not IID, independent and identically distributed, right? It's messy. It's full of all these other things. And also now this is other element that I've been thinking about more is like someone can mess with it, right? Like someone could actually like mess up my model so it starts learning all these bad things. So now, I don't know, I just feel like there's so many interesting things to talk about, but I wanted to kind of shift towards, I guess, the future. I want to just hear your thoughts and what you think about MLOps in this space and where that's heading. So one question I have is, what do you see as being some of the principal challenges that we have right now in productionizing machine learning? And in particular, what are those challenges in comparison to 2015 when you first started writing some of these papers? You mentioned a little bit of this earlier, but yeah, just what are your thoughts on that? Where are we headed?
Yeah, super interesting stuff. So, you know, I will say, you know, I used to work in this field a lot, and you know, I'm certainly happy to give my thoughts, but there are likely people who are more in the day of it right now than I am, who will have better thoughts than I do. But so with that said, you know, looking forward, it's one of the very obvious trends of the last couple of years has been that models keep getting bigger. I mean, OpenAI has these really nice papers on like, you know, scaling laws of large language models and stuff like that. That basically, you know, show a exponentially increasing model size over time. And yeah, that carries with it a couple of interesting challenges. You know, like I think it's very reasonable to assume that models are going to keep getting bigger until they just can't, for, you know, whatever reason, where like you know, just resources become inconceivable for larger models. So they're going to keep getting bigger for a while, in my opinion. What's interesting about scale and scaling up is sort of like, why is this happening? And the reason in my read of the situation is that basically, you know, as we get more and more data and more parameters for the models, it's not that we're doing a better and better job of learning on the common data, right? Like the common data, you know, like the typical data, you know, getting more and more of that isn't that much more useful than just taking many more gradient steps on the same, you know, data set that you already have. Instead, as we get larger and larger data sets, what we get is more and more exploration of the fringes, and sort of rare edge cases, and atypical data. You know, so like you can think of, you know, gathering a huge data set as a slightly inefficient way to gather, smaller data sets that are sprinkled all around the interesting areas of the data space that you haven't already covered. Why do I say this is interesting from an MLOps perspective? Well, it's because as we expose our models to more and more edge cases, or try and cover more and more specifics, I think that this means that there are more and more potential places where our models might be exhibiting unexpected or undesirable behavior. And so our need for stress testing, I think, also grows with the scale of the data that we're talking about. And if you look at those graphs and you look at that log linear scale or whatever it is, like, it's certainly something to think about. For MLOps perspective, maybe that's great. Maybe it's job security. I don't know, but it's certainly something that's going to require a lot of attention as models keep getting larger and larger. Let's see, other things that are interesting. I think federated learning is super interesting from an MLOps perspective. So federated learning, this is the area where it's a great privacy preserving mechanism. Like you could imagine data is stored on, lots of devices, maybe people's phones or whatever. We don't want to take the data off the device, but we're able to sort of do this very, very distributed, federated training where model training is done sort of little bits at a time on the individual devices. The data never leaves each device, and sort of anonymized, very, highly private, highly secure updates get sent back and forth. It's fascinating. It's fantastic. I have no idea how to make that operational from an MLOps perspective. What does reproducibility in that situation look like? What does data testing look like in that regime? I'm not working on federated learning. There are people who are really smart and are working on that, and they probably have great answers. But just in terms of like thinking of the future, I think that the MLOps community would do well to focus on that a little bit at least. We've talked a little bit about the proliferation of devices. I think that there's just going to be more, and I really hope that we get more and better abstractions that help us deal with that over time. But for the time being, there does seem to be a lot of the classic write once, debug everywhere kind of framework that we've often seen in similar situations, like web pages in the 1990s or whatever they might have been. Let's see. How about you? What are your thoughts? You guys are doing this every day.
You've definitely given us a lot to talk about. I think, at least from my perspective, my experience as a machine learning engineer at a startup company has really been realizing that a lot of the problem is defining the problem more so than it is writing the models, even writing software, right? It's like, okay, we work on retinal images, which is actually one of the interesting things that you guys talked about in your underspecification paper. And a lot of my time is spent, well, what are the ways an image can be bad? How do I go gather an understanding of that and think about what that means algorithmically? And also just even from the annotation standpoint, how do I make sure that my annotation is reliable? It is for the machine learning engineer, it's almost a lot more meaningful to spend time thinking about your labels and making sure your labels have that sanctity than it is to actually spend writing tons and tons of lines of code.
Oh, that is so true. I mean, like the amount of bang for your buck that you get, either A, spending your time like trying to think of a slightly different mathematical formulation for your model, or B, spending time making your rater guidelines more specific. Like, I mean, B wins every day, right?
Yeah, that's exactly right. And I think the nice thing to see is that there's interesting tooling that's coming out for that. Companies like the Label Box, and I think there's one called Superb.ai. They're proposing new ways of basically making that whole process more efficient based on some research that's coming out. And I think that could be really promising from an MLOps standpoint, because if it's a lot easier to make, if it makes my life easier when it comes to annotations and getting fewer annotations but being able to have a higher level of confidence in them, that's the holy grail, right, for any kind of assembling any kind of data set. What about you, David?
So I'm like, my interests are more in the infra side of things, thinking about, like you mentioned, like the models are getting larger and larger. How do we have efficient inference? And I think that problem still needs some work. Like I look at some of the things that I would love to work on, like a better scheduler, the ability to share resources more efficiently, and hopefully abstractions that make it less, like, I don't know, like using like specialized hardware isn't always trivial. Sometimes you have to, make sure you have all of these drivers there. There's a lot of things that make it tricky. I would hope that gets better. And I do think that's so important. It's like the infrastructure is what everything runs on, and when that's not working well, everything gets slowed down. So I think that's something that we all realize. It's just not talked about much, but there is definitely some cool work being done on improving that, and I would love to see more of that. I guess I envision that being also a priority. But another thing you kind of were talking about was like security. There's this, I think it's called multi-party computing, or secure multi-party computing, which seems similar to federated learning. But like you said, how do we actually do that at scale? Like how do we actually make that doable? And I think that spending more time understanding that from an ML perspective is going to be where we're going to invest more time. Again, also, I'm saying like the same answers, but the data, it's always about the data. Labels in particular is also a really interesting area, finding ways to do that in an automated way. So I definitely see more focus on actually like making some of these jobs feasible from a computing point of view, that we can do it where our resources, we're not spending so much money. So I'm thinking about like GPU sharing, a way to make the most out of what we have. And then definitely security, making some of these secure methods more mainstream or more popular, because I see them as kind of small little areas of research rather than something that everyone's doing in production.
Well, yeah.
So maybe there's ways to make that simpler, make that more available. These are things that, again, as an ML engineer, I didn't really worry about too much, but now security is becoming so much more important, fairness and bias, and addressing some of these issues, that it's less model specific, less about the algorithm and more about everything else that's going in this environment, what's going into that algorithm.
That's something I'm glad we're on the same page, David, because I was going to mention security too, and talking about also everything that you mentioned, but then you said it beforehand, like when people start playing with your models and people are trying to train them in a nefarious way, like how do you prepare for that? What are you doing in those cases? And is this the job of the MLOps or the machine learning engineer, the infrastructure team? Like
it's not my job defense.
Yeah,
I
exactly. Exactly.
Yeah,
because
I don't think I buy that one.
yeah, that's exactly it. Like, well, is there a new, I mean, Vishnu and I have talked about this quite at length, of the like splintering of the ML engineer, and how is there going to be, like, you've seen DevOps go into DevSecOps, right? And is there going to be a ML, I don't even know how we could put it, ML SecOps come about in the future too? So that's something that I just wanted to tack on to the end of what you were saying. But Dee, I'd love to hear your thoughts on all of that.
Yeah, no, I think all of these things are very, very plausible, very likely. I was looking back, I got to reread the tech debt paper this morning and trying to remember what was in it. I saw, the old figure one there. That's like the figure with the little, the little bit of machine learning code in the middle, and then like the different system pieces on the outside. That's a paper that I've seen. That's a figure that I've seen crop up in
Legendary.
really, a wide variety of corners of the internet. So that's been pretty fun. But looking at that figure again, what I noticed, in terms of like what's missing from that, there's likely, some pieces that are missing in terms of, I think there was a box for data validation, but sort of like the full-on security, whether it's spam filtering or like, kicking bad actors out of your feedback pipeline or whatever else, like that's a really big deal in a lot of cases. And then on the output side, it's often the case that, for example, like for a lot of models that are used in different production settings, like you don't necessarily want to take the raw output of a model and feed it into your production setting unfiltered. And we've all seen, high profile cases of, like chatbots or whatever else, like maybe needing some filtering or stuff like that, right? And I think that those kinds of pre and post parts of the system are really important. There are also places where you could absolutely accrue, a fair bit of technical debt in your system, or like something that gets like really hard to change or gets sort of like frozen to a particular version of a model or things like that. And looking forward, I think that those are areas that could have, like whole communities around them themselves in terms of like best practices and infrastructure development and all the rest of it.
I have one question also as a follow-up with that, like sort of like how in your opinion, you've seen a bunch of communities come up, go away. How does that affect this, like the space, like the community? Is that, I don't know, I haven't been around long enough to think of other communities that have like accelerated the development of things, or maybe, I don't know, maybe not made it worse, but I don't know, I feel like communities they play an important role. Like I look at a project like Qflow, or maybe one of these other ones that are open source, where if there is a lot of people actively working on it, it actually makes the tool more likely to be adopted by another team. I know when we were evaluating our infrastructure and what tooling to use, that was a big thing. Like, is there a community around this that if we have a question, we can ask? Are there people that are actively working on this? And so going back to my question is, how does that shape the development of the MLOps sphere? I guess in this, like, and maybe if it doesn't have to be MLOps, some other community that you've seen, and maybe how that affects, I don't know, research or whatever area you've seen.
Yeah, so just like, having dramatically more training data gives you more information at the edges. I think that having a larger community, it's one way of, having better faith that you are getting stress tests in a wide variety of important edge cases, where those stress tests are probably, from different, domains or different companies or whatever else. But, it's much better to have one large community than three smaller communities because of those edge effects. And sort of the ability to learn from people who are doing something that's a little bit, different than what you might be doing or what might be standard practice at the current time.
That makes a ton of sense. You're very talented at analogies.
You should have heard his, sorry to butt in, Vishnu, but he has a recording with a software engineer daily, and he did a spamming one in the, Norway and Sweden about spam.
And it's good?
And you probably don't even remember doing this. You probably came up with it off the cuff, but it was, for me, I was laughing, like, how did he just come up with that analogy and this example? So anyway, go ahead, Vishnu. Sorry for.
No, I'll have to go back and listen to that one specifically then for that analogy. My question kind of is, it's almost about idea communication and how you think about that, right? This concept of technical debt in machine learning, I see that the 2015 paper was, one of the first one, I think, really pushing that term, really helping people understand that this is the concept that you need to keep in mind. As you sort of hear about perhaps this new idea like underspecification and stress tests, how do you think about, or how do you go about the process of like, maybe formalizing this idea and then communicating it to the people that you work with? I'm just curious how you think about it. Maybe it's organic, maybe it's a little bit more, structured as the way maybe I'm applying too much structure to it, but I'm curious how you think about communicating some of the ideas that you have about how to engineer systems properly.
Yeah, I mean, I do think it's one of the reasons to write papers and publish papers. I think it's a really good practice. For myself, the best thing about writing papers is to like actually try and figure out what I think or what is true. To the best that I can or we can. I think that to first approximation, science is what happens when you write stuff down, and without writing, it's very, very difficult to really have something that's solid, that can be put up for debate or for inspection, can be disagreed with, can be critiqued. So that's step one. Well, once things are written, then there's a little bit of publication and things like that. I imagine that you guys are probably better at that than I am, but. I think that good ideas tend to make their way into the community if they're in a form that people can digest and share. I don't think that we need to like wrangle our way into 60 minutes to talk about MLOps or technical debt. I think that, making sure that, number one, there are good papers out there. Number two, where we can create useful pieces of infrastructure, whether it's an open source or other shareable or usable things, that can help a lot for adoption if we have some best practices that can be adopted that way. And then things like this, of just having conversations and sitting and talking with people, I think it's really, really useful.
Are we going to see a book anytime soon?
Nope.
From you? No books? No.
No, I don't think that's very likely for me.
Well, amazing sitting down or Zoom or whatever we're doing here across the internet and talking with you. I really thank you for taking the time to do this, because I know that it is very valuable for everyone that is out there listening. And if anyone wants to get in touch with you, I think we can direct them to your website, which is an incredible website. We'll leave it in the links below. There is an FAQ section, and this is how I knew it was going to be a great chat, because I think the FAQ, one of the questions in the FAQ section was, is your name really D? And the answer was, yes, it is.
I think that might be the only FAQ on that. But anyway, thank you. I really appreciated the chat. It's great to hear about your view of the work. So thanks so much.
Yeah, thanks again, D. And we will see everyone later.
Yeah, peace out, guys.